Many moons ago, when we were actually in class together before all the snow set in, we spoke about domain and range. And we said that domain had to do with our X information, and our range had to do with our Y information. And we looked at an example where we defined our domain and range by looking at sets of ordered pairs that we were giving and making a list of all the X values for the domain and all the Y values from the range. Now we're going to take a look at getting that same kind of information, but we don't have a list of coordinate pairs. We could make a list of coordinate pairs from our graph, but we're not going to do that. We're going to pull the information just by looking at the graph. Let's get started by identifying our X and our Y axes, because it's important to be able to see that information. Domain has to do with X, and our X axis here is the axis that goes from left to right, left being small negative values that get infinitely smaller, and then over here, X values that are positive and get infinitely bigger. That's just X in general. For our domain, we want to look at the X values that are shown by the graph of our function. So we're going to start from the left and see what our first value is for our function. And we see that the first value is this point here. Because we're looking to identify domain, this point does have two values associated with it, an X and Y. Because we're looking for domain, we want the X piece of information. So we're going to come down to our X axis here, and this is where our domain starts, at this value here of -1. And notice that I use the parentheses, and I'm going to use the parentheses here because this open circle says it starts here, but that point is not included. Continuing on, in our graph, we see that we continue, X gets bigger and bigger and bigger, moving to the right, and then finally here at this point, our graph stops. Again, we need the X piece of information associated with that point. So we're going to come down to our X axis, and that is the end of our domain. That point there, X is 4. So the domain for this function goes from -1 to 4. 4 has the bracket because our point is included. Now let's consider range. Range is Y information. And labeling my Y axis is the axis that goes up and down. And so for purposes of our domain, we're going to start from the bottom and go up. With our range and domain, we always want to start from the smallest values to the largest values. So that's why for X, we go from left to right. And from the domain, we're going to go from the bottom up. So coming up from -Y territory, we have nothing going on, nothing going on, nothing going on. And then the first value of our function in regards to Y is this point here. So again, similar to X, even though this coordinate has two values associated with it, X and Y, because we're talking range here, we only want the Y piece of information. So we have to come back here to our Y axis, and at this point here, we have a value of 1 and bracket because that 1 is included. Now our function continues up, and our largest value of Y is this point here, where, come back to our Y-axis to identify it, we are at 3. So our range is 1 to 3, 3 being parentheses because that point is not included. Now let's take a look at intercepts. Domain and range are intervals of information. X and Y intercepts are specific points. So when we look here, intercept means where we either cross through or touch an axis. So for our x-axis, we see that we don't have any place where that happens, so there's going to be none. There are no x-intercepts. For y-intercepts, when we look, we see that we do cross through the y-axis there, which is 1, 2, I'm going to say about 2 and 3/4. It's not quite 3, it's a little bit bigger than 2.5, so we'll just approximate. And again, x and y intercepts are not intervals, they're specific points. Looking at this example, again, domain has to do with x and range has to do with y. X, y, x, y. Let's look for the smallest values of our domain. We start here on the left, negative x territory, and start moving towards the right. And we see at this point here, our function starts. So we don't have to go down to the x-axis because we're at the x-axis there, and that point is included, and that point x is 3. As we continue to move to the right, we see x is getting bigger and bigger and bigger. And for this particular function, this arrow says that we're not going to stop. We're going to go on forever. So in terms of our domain, we start at 3, but we go on to infinity. In this example, our domain was a specific interval with a beginning and an end. Here, again, we have a specific interval with a beginning, but we go on forever. And you might see that in certain examples where you have infinity for one part of it, maybe 2 parts of it, maybe no part of it. Our range, we look for the smallest value of y. Starting down here, we see there's nothing going on in negative y territory. So we go up, 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 and then we see that the first value of our function here is, and we have to go back to the y-axis to define it, is at 0. So along our y-axis, we're starting here at 0. And now we can see that our function, it's going up not very quickly, but it is going up. And this arrow says it's going to continue to go up indefinitely. So our range starts at 0 with a bracket. And then again, we're going to go to infinity because we're going to go on forever. X-intercepts. We see that we do have this point here where we touch the x-axis, and that happens at x is 3. Y-intercepts. Looking at our y-axis here, there is no point at which our function either touches or crosses through our y-axis, so there would be none. This example here. Again, I failed to label my axes here. X, Y, Y, X. Domain, again having to do with X. Smallest value is going to sit on the left-hand side of our interval. Coming from the left, the first value we encounter for our function is here, and we need to go down to our x-axis to identify it. And that point there happens at -1, -2, -3, -4. So our domain starts at -4, and that's going to be a bracket. We continue on, our function continues, 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 and then we end here. Again, we need to describe this in terms of x. So this has the open circle. I'm just going to put a parentheses there. And 1, 2, 3, our domain ends at 3, and that's going to be a parentheses because that point isn't included. For our range, y behavior, starting from negative, starting from the bottom, negative y territory. Let's go up and see what the first value is for our function, which is this point here. Going back to our y-axis, we can see that that value there is -2. And again, it is bracket. Let me just point out here, even though this point doesn't have a very dramatic filled in circle to say, yep, it's included, because our function is a solid line, that point is included there. Increasing along the lines of our y-axis, we start here at -2, and our function increases this way, and it also increases this way. We want to increase to the largest y value, which is represented by this point here. So we come back to our y-axis and identify that point there as 2. So our range in this particular example goes from -2 to +2, and all the values in between. Looking at intercepts, x-intercepts, we have one over here. Let me change up my color marker here. So we have this point there where x is -3. And then we do have this point here that looks like we have an intercept with the x-axis, but when we look more closely, the open circle says that it's not included. So looks like it might have been, but no, it's not. In terms of y-intercepts, we can see that we cross through the y-axis here, where y is -1. So those are our two intercepts. And oh, by the way, we could always write these. I've just identified the values, but we could always write these as coordinate pairs. So our x-intercept would be -3, 0, and our y-intercept would be 0, -1. These look like a range. Be careful. I shouldn't say range. They look like intervals that we use for range and domain, but in this case, it's representing the specific values of a point of a coordinate pair.